Now, we said a few moments ago that data science begins with data. Well, if it begins with data, the next part is clearly science. And this that we're looking at now is the scientific approach. That is, you start off by observing the data. You then draw hypotheses of how the data could be used to answer a specific question. You then develop experiments that prove or disprove those hypotheses, draw conclusions based on those experiments, and make adjustments to your thinking and to your code, and then you repeat it again. And that fundamentally is the scientific method. However, with experimental data science, this loop has to be repeated for every single avenue that needs to be explored to answer the question that's been given. This means that you could be repeating experiments or repeating this loop many, many, many times before a usable model is landed on. Even then, many loops may be needed again to improve the accuracy of that model. And that leaves us in a position where we might be looking at something a little bit like this. This is a binary system. That is, for every experiment, there are only two possible outcomes, outcome A or outcome B. But the thing is, data science isn't binary. Nonetheless, using this as an example, you can see that just 5 rounds of experiments have led us to 31 different possible outcomes. And a data scientist could conceivably complete this number of iterations in 3 to 4 days. However, perhaps a slightly different system exists where there are potentially 3 different outcomes. Now, in this version, just 3 iterations puts us in a position where we have 36 possible potential outcomes. That's less number of experiments and a greater number of outcomes. In all honesty, though, data science is a little bit more like this. That is an unpredictable number of iterations and an unpredictable number of outcomes. And this is the reason why it's very difficult for a data scientist to estimate how long something is going to take. They simply do not know. They don't know how many times they have to repeat the experiment. They don't know how many different outcomes there could be from that experiment. And they don't know what experiment they need to conduct after those outcomes have been completed. So although they might be able to talk about the experiment they're doing right now, they might be able to talk about the potential outcomes for it and what impact that might have on what they do next, they generally cannot talk any further ahead than that. That means they cannot even predict their own work, and they cannot estimate their own work, because it is you're asking them to look too far into the future, and there are too many different permutations that could lead them in that direction. And that means that fundamentally, the data science approach, in this case, the scientific approach, in this case, the experimental data science approach, in this case, is not predictable. But Scrum relies on predictability to manage our work in progress limits. We do this through velocity. The velocity tells us how much work we can pull in every single sprint and how much work is going to get done every single sprint. If a data scientist is unable to tell us how much they're going to get done in 3 to 4 days, how are they going to be able to tell us what they're going to get done in a sprint? And this, by definition, puts us in a slightly difficult position. It means, fundamentally, Scrum does not work for experimental data science projects. But it does work for engineers, and it does work for ML engineers. So what do we do?